Hey everyone, I'm your host Adrian. We do content like this weekly, so hit the subscribe button and ring the bell to get notified. If you want more content like this, click the like button and please leave a comment. Thanks again for watching. Welcome everyone to today's Rupa Live class presented by Rupa University, the best way to learn about specialty lab work from industry experts. My name is Adrian Martinez, and I will be your host for this afternoon or evening for those folks joining us from the UK. Today, we have a very, very special guest in Dr. Tom Fabian with Diagnostic Solutions, here to walk us through mast cells, microbes, and metabolites in IBS, breakthrough insights with GIMAP. Before jumping in, a couple of quick housekeeping items. Everyone joining us will be muted by default, but if you do have any questions, go ahead and use that Q&A button down in your menu bar, and we will host a live Q&A session at the end of the presentation with Dr. Fabian. Immediately following the Q&A, yours truly will show you exactly how to order the GIMAP on Rupa Health. So stay tuned if you are interested in ordering this test. And if you have to jump early, no worries at all. We are recording this session and you'll be able to find it on rupauniversity.com within the coming days. Additionally, we'll go ahead and send you out an email with a copy of it as well. And additionally, if you are a fan of this type of content, be sure to check out rupauniversity.com to get access to all the previous sessions that we have done. So with that, let's go ahead and jump in. I'd like to introduce Dr. Tom Fabian. Dr. Fabian is a leading expert on the role of the microbiome and health, immune function, chronic disease, and aging. As a translational scientist, his primary focus is on the clinical application of microbiome research in the integrative and functional medicine space. He received his PhD in molecular biology from the University of Colorado Boulder, go Buffs, and has worked as a biomedical researcher in the biotechnology industry, and more recently as a consultant in the microbiome testing field. Currently, Dr. Fabian serves as a consultant and science advisor with Diagnostic Solutions Laboratory, and he is also a science advisory board member with Designs for Health. In addition, he is certified as a nutrition therapy practitioner by the Nutritional Therapy Institute in Denver. Thank you so much for joining us, Dr. Fabian. I will go ahead and let you take it from here.
All right. Well, thanks so much, Adrian. I really appreciate that introduction. And welcome to everyone who's joining us. So today we're really going to dive in here. Actually, I just advanced my slide there. So we're going to dive into this topic of focusing on mast cells, microbes, and the related metabolites that they produce that have been linked to IBS through recent research. So what I'd like to do today, primarily, just kind of give you a high-level overview, is we're going to start off with some introductory information, background information on IBS, and then really diving into some of the key research developments that have come out just in the last couple of years or so that's shedding a lot of light on the role of the microbiome in IBS, particularly these various metabolites or microbial products that they produce that are thought to play a role now in IBS and various subtypes of IBS. So I really want to focus on that and then also talk about how we can get great insights into these various factors with comprehensive stool testing with GIMAP. So that's really going to be the focus today. So I wanted to start off with this kind of an overview definition of IBS. This is sort of the traditional viewpoint of IBS. So of course, currently the diagnosis of IBS in conventional medicine is based on what's called the Rome 4 criteria. And that's essentially summarized here in this quote from this recent review article. So they say, based on the current symptom criteria, IBS is defined by chronically recurring abdominal pain associated with altered bowel habits and the absence of detectable organic disease. So really, I want to focus on a couple aspects here. So I underlined and emphasized the abdominal pain aspect. That's one of the key differentiators of IBS, one of the key symptoms for diagnosis, along with some sort of altered motility, typically, of course, constipation or diarrhea, or some sort of mixed or even the undefined type of diarrhea. That's a fourth subtype now. And this is really what these new insights are focusing on and revealing some key insights into what may be causing the abdominal pain, and especially the role of the microbiome, and also what may be leading to the altered motility. So that's really an important piece that we're going to be looking at today. Also, to kind of set the stage, one of the things that can be a challenge for practitioners working with IBS patients, especially those who have not yet been diagnosed, is the fact that because IBS is a symptom-based diagnosis, those types of symptoms are actually fairly common and overlap with a long list of diseases and conditions. So this is a table that's featured in that review article I just increase the size here so it's easier to see. So you can see IBS listed here. And this is essentially a table for looking at and sort of helping practitioners understand differential diagnoses for inflammatory bowel disease. So that is one of the conditions that features symptoms that can overlap with IBS. So you can see here for IBS, the typical symptoms are abdominal discomfort, bloating, diarrhea or constipation, abdominal distension, and often a sensation of incomplete evacuation or urgency. But also there are a number of different conditions that can lead to similar symptoms. So you can see here for bile acid malabsorption, diarrhea typically is the main symptom. Exocrine pancreatic insufficiency, similar symptoms once again to IBS. Carbohydrate intolerance, small intestinal bacterial overgrowth, small intestinal fungal overgrowth, different types of motility disorders, including Ehlers-Danlos syndrome, and then various mast cell and immune activating disorders like mast cell activation syndrome, eosinophilic gastroenteritis, interabdominal adhesions, and other conditions like celiac disease and also Giardia infection. So this is a pretty daunting list when practitioners are trying to figure out when a patient presents with these common symptoms, is this really IBS? Is this some sort of other condition that may lead to similar symptoms? Also, it turns out that histamine intolerance is another condition that can overlap with the symptoms of IBS. So you can see here, this is a figure from a recent review article. Full-blown histamine intolerance often has systemic symptoms that affect the respiratory system, nervous system, circulatory system, and skin, but especially the gastrointestinal tract. So you can see here some of the key symptoms like bloating, flatulence, diarrhea, abdominal pain, or constipation are also common features of histamine intolerance. So it turns out that these different conditions, even though they are recognized as separate conditions, some of these underlying pathophysiological factors may be in common with IBS. And we'll actually see that as we go through some of this research evidence here today. This is another recent review article by a couple of the leading researchers in the IBS field, Drs. Camilleri and also Dr. Buckstains. This is titled Irritable Bowel Syndrome, Treatment Based on Pathophysiology and Biomarkers. So the idea is here with all this new research that has been coming out in recent years that's helping us better understand some of these underlying factors that may contribute to IBS in different patients and different subtypes, that we can now start to move towards a pathophysiological perspective in diagnosing IBS and also just understanding some of these underlying imbalances so that we're not just looking at symptoms and treating symptoms. So this is a major focus in the field now in terms of translating all this research into clinical practice. And this is a quote from that article where they say the widespread availability of non-invasive clinical tests that can appraise the mechanisms responsible for symptom generation in IBS provides the opportunity to advance the practice from treatment based on symptoms to individualization of treatment guided by pathophysiology and clinically identified biomarkers. So again, that's really an important focus of where this research is heading. And some of that is now potentially applicable in a clinical setting. And especially, I want to draw attention here to this individualization component. So of course, in our field, we're all familiar with the importance of personalization, really tailoring what we're doing for individual patients to what's going on specifically for that patient. And so it turns out that as we're learning more about IBS and these underlying factors, we may be able to recognize what may be going on for each individual patient that may be a bit different from patient to patient. So it's not sort of the same pattern for all patients. This is a really important review article. If you can get a hold of this one, it's titled Increasing Evidence That Irritable Bowel Syndrome and Functional GI Disorders Have a Microbial Pathogenesis. So in here, we're really looking at linking what's going on with the microbiome to these underlying pathophysiological processes in IBS. There's a key figure in this article that I want to focus on, and this is titled Schematic Representation of IBS Pathophysiology. I'm going to go ahead and just enlarge this a bit so we can look at it a bit better. And then focusing on this center part here. So this is really kind of the summary of what's coming out of all this research in terms of the key factors that are thought to play central roles in this underlying pathophysiology of IBS. And that includes dysfunctional microbiota, increased intestinal permeability, immune activation, which is really important. We'll be talking a lot about particularly mast cell activation, also visceral hypersensitivity. So of course, that's one of the key underlying factors related to abdominal pain. So one of the key symptoms in IBS, and that's noted here. So these various factors then can lead to chronic abdominal pain or discomfort, bloating, and also altered motility. So we can summarize these pathophysiological mechanisms as microbial involvement. And I'm going to go through a couple different aspects today. So there's potential GI infections that can trigger IBS for some patients. And those can actually set the stage for later development of IBS. And then ongoing dysbiosis, which can be responsible for ongoing IBS symptoms in many patients. So that includes specific microbes, as well as some of their key products that they produce. There's also immune activation, and we'll look at how those two may be linked, the different microbial products and different microbes, what they're producing, and how that can lead to immune activation, which often includes increased mast cell activation, sometimes eosinophil activation, and it's often induced either by foods or microbes or both. Then there's the facet of visceral hypersensitivity that causes the abdominal pain and discomfort, and also altered motility, again, that are often induced by these microbial products and or the immune activation. And then, of course, another common feature of IBS is intestinal barrier dysfunction. This can also be caused by the dysbiosis and also immune activation. So we'll look at that as well. Let's start off and focus on this microbial involvement piece. We can really break that down into two parts. So in terms of the microbial involvement, we have pathogenic infections. So these can lead to gastroenteritis that's often caused by various types of pathogens that are bacterial, viral, or parasitic in nature. And they can initiate the development of post-infectious IBS. We're also going to look at the known commensal imbalances and opportunistic overgrowth that are often associated with IBS. And those can involve deficiency or excess of these microbial products that they produce that can then contribute to active IBS symptoms and also the pathophysiology. And before we dive in, I just want to note that to be able to assess the microbial involvement in IBS, we can take a look at this comprehensively with comprehensive stool testing through GIMAP, which allows practitioners to assess the whole microbial ecosystem in terms of pathogens, opportunists, and then representative normal microbes and how they interact with our physiology. So that's a really important component to understand in terms of not just IBS, but a wide range of conditions, is what microbes are possibly playing a role, and then also how are the microbes interacting with these physiological imbalances. They may cause certain imbalances, and then in turn, these imbalances, such as poor digestion, inflammation, can actually promote dysbiosis. So it's really essential to have a tool where you can look at all these different aspects of gut health so that you can connect the dots for your patients. So just a brief overview of comprehensive GI health assessment with GIMAP. GIMAP includes common pathogens that can cause gastroenteritis that are often involved in that sort of initial trigger for IBS, opportunistic microbes that are often involved in sort of continue to promote the symptoms in IBS, normal microbes that may be imbalanced in different subtypes of IBS. Of course, immune responses, we'll talk more about that as well and how they may be involved. Intestinal barrier integrity, we just talked about that being a key feature of the pathophysiology of IBS. Digestive function can be assessed, and then other markers of gut health as well. It's a very comprehensive set of markers to provide practitioners with important insights into what may be going on for each individual patient. We also provide some additional resources. So in the interpretive guide, which was recently updated, we have some additional resources for practitioners to help you understand different functional categories of microbes. So we know that certain microbes can produce histamine, for example. Several microbe types can produce the various intestinal gases, such as hydrogen, methane, and hydrogen sulfide. We also have microbes, of course, that can produce lipopolysaccharide or LPS, which is well known to contribute to inflammation, and also microbes that can stimulate mast cells, which are now thought to be a key part of IBS, as we'll see. So this is a really essential resource, and this will be available to those of you attending the webinar. Also in this resource, we have kind of the broader view of looking at the intestinal barrier and leaky gut. So we do have the zonulin marker, which is a direct marker for leaky gut, but there are other aspects to the intestinal barrier that is important to assess. And that's what this particular resource can help practitioners with, is understanding what microbes can give you some insights into the state of the barrier, and then other markers on GIMAP, such as secretory IgA, for example. All right, so in terms of the microbial involvement in IBS, let's dive in a little bit to the pathogenic infections that can actually initially trigger IBS. So this is a figure from a recent review article. You can see the reference here at the bottom, and the various microbes, and this is just a subset of the ones that have been identified so far, but these are among the most common. So you can see that there are various pathogens listed across the top of the figure, from E. coli pathogens, Shigella, Clostridium difficile, Salmonella, parasites, and also viruses. And all of these are known to potentially cause post-infectious IBS. So let's look at some of what these microbes can do when they cause an infection. So they certainly are known to cause epithelial barrier disruption. They can cause acute inflammation that in some cases doesn't resolve and can lead to chronic inflammation. Then they can initiate dysbiosis. So they can basically disturb the ecosystem, such as disturbing microbial diversity, decreasing the beneficial bacteria, etc. And then all of that potentially for susceptible individuals. Certainly not everyone that has gastroenteritis goes on to develop IBS, but a subset certainly do. The figures vary depending on the studies. On average, it's roughly estimated to be around 10% of people who have gastroenteritis may go on to develop post-infectious IBS. So a pretty common phenomenon and pretty common cause for IBS. On GIMAP, our first page includes many of these types of pathogens. So you can see here we have the various bacterial pathogens at the top. In this case, this patient was high for the enterohemorrhagic E. coli. So that is one of the E. coli pathogens that potentially can go on to cause IBS for some patients. This patient also had trace levels of Giardia under the parasitic pathogens. Trace levels are generally less likely to cause significant problems. Really, for parasites in particular, higher amounts are typically required to cause significant symptoms. So this could just be a transient asymptomatic infection. We also have certain viral pathogens as well, and in particular norovirus is thought to be another cause of post-infectious IBS. And this is a recent review article that talks about a major study that was published just last year that shed a lot of light on one of the key mechanisms for how these infections may lead to at least a subtype or a subcategory of IBS. So this review article is titled Understanding the Immune Drivers of Food-Induced Abdominal Pain. And this is just an excerpt from the article where they say a new paper published in Nature, which we'll actually take a look at momentarily, explores the underlying mechanisms and links between infection, IBS symptoms, and food intake. So those three things have been known to be connected in research, but it wasn't until recently that we had some new research identifying what these particular links actually may be. And they go on to say, the research reveals that bacterial gastrointestinal infection can trigger a break in oral tolerance and a localized immune response that reacts to food antigens, leading to meal-induced abdominal pain. So this does appear to be, for some patients, sort of like a food sensitivity or food allergy type reaction that can develop after the initial infection. So this is the actual paper that they're referring to, titled Local Immune Response to Food Antigens Drives Meal-Induced Abdominal Pain. This is published in one of the top journals, Nature, just last year. And this is a quote, a really interesting quote, I think, from the authors in the article where they say, based on our data, we propose that IBS, at least in an immunogenetically susceptible subgroup of IBS patients, is part of a spectrum of food-induced disorders mediated by mast cell activation, with systemic food allergy at the extreme end of the spectrum. So this is a really new perspective here that's coming out of this research that at least a subset of IBS patients may be on this spectrum that's actually sort of related to food sensitivities and food allergies, where their symptoms may be triggered by specific foods, and that originally was triggered potentially by these gastroenteritis type infections. So really, very interesting research. This is another really interesting review article that was just published this year, Mechanisms Underlying Food-Triggered Symptoms in Disorders of Gut-Brain Interactions. And that's sort of the new term actually for IBS and other related functional GI disorders. That was sort of the old term, functional gastrointestinal disorders. This new term is disorders of gut-brain interaction, to recognize this gut-brain connection as a piece of the puzzle. And this is an excerpt from that article. It says, the landmark discovery that mast cells are activated in the colon and small bowel of IBS patients, that they are closely associated with intestinal nerves and their mediators, particularly histamine and proteases, and that activation causes visceral hypersensitivity, has directly implicated the immune system in IBS pathophysiology. So again, this is recognizing just how important these connections are that are coming out of the research. All right, so back to our two aspects of the microbial involvement in IBS. So we just did kind of a quick overview of the role of pathogenic infections and one of the leading models for how infections may cause IBS symptoms, at least in a subset of patients. Now let's go ahead and talk about the role of the commensal microbes and their imbalances, as well as overgrowth of certain opportunistic microbes. So this is kind of a short list of microbes implicated in IBS pathophysiology. So there are various studies out there looking at these associations for microbiome patterns, specific microbes, and then IBS in general, or correlations with different subtypes of IBS. And overall, there's not a lot of agreement among those studies, although now that we're getting into more of the mechanistic studies, there are specific links now for some of these microbes to IBS. And part of the lack of consistency over time in some of these studies may be due to this fact that individual microbes may not matter as much as what they're producing. And then also this individual aspect where there's differences between patients in the specifics of what may be causing their IBS symptoms. But these are some of the best studied ones so far that have been linked to IBS based on potentially various mechanisms. So we'll talk about a few of these today. There's also microbial products that are now implicated in IBS pathophysiology, with probably the one that's best supported at this point, especially based on some new research that just came out earlier this year, is histamine. That's why I've emphasized that one. That does seem to play a pretty prominent role in causing this visceral hypersensitivity, abdominal pain aspect of IBS, but also may contribute to altered motility. But there's also a number of other microbial products that are now well studied and thought to also play a role in IBS, at least in some patients. And that includes serotonin, something called tryptamine, lipopolysaccharide, which I think most of you have heard of, bile acids and their derivatives, short-chain fatty acids. We'll look at that as well. Certain enzymes that are produced by microbes, including proteases, and then, of course, gases such as hydrogen, methane, and possibly hydrogen sulfide. And this is a quote from one of those articles that I featured a little bit ago, Mechanisms Underlying Food-Triggered Symptoms and Disorders of Gut-Brain Interactions, where they say diet microbiota interactions are a critical source of neuroactive mediators that significantly modulate intestinal, nociceptive, which means pain signaling, and cause visceral hypersensitivity. Multiple bacterial mediators have been implicated, including histamine, proteases, tryptamine, 5-HT, which is the chemical name for serotonin, and then lipopolysaccharide. So again, those are some of the best studied ones that are thought to be involved in causing the abdominal pain aspect of IBS. There's also metabolites that are more directly linked to altered motility, and that's summarized here in this recent review article, where they say the gut microbiota produces metabolites such as short-chain fatty acids, secondary bile acids, tryptamine, histamine, hydrogen, or methane. These microbial-derived metabolites can influence gastrointestinal motility and thereby impact gut transit time. And this is actually a figure from that review article for those of you who like to see this a bit more visually. So you can see the title here at the top, that it's basically showing us the metabolites that are derived from the microbiome that can have effects on the intestinal epithelium and the mucosa and how they may affect gut motility. Just quickly across the top, you can see here examples of, metabolites produced by tryptophan, tryptamine, bile acids, short-chain fatty acids, butyrate, and then also histamine, and then the various gases we just talked about. And those can have various effects, particularly through different types of receptors on different cells in the epithelium, and also effects on enteric nerves and the enteric musculature as well. So that's thought to be how these can affect motility, and those are some of the best studied metabolites. So again, you can see here, this is back to our summary of the key pathophysiological mechanisms. We really know that there's microbial involvement, a lot of research on that now. There's also immune activation that happens in most patients. Visceral hypersensitivity and altered motility are key features of IBS and thought to be induced by the microbial factors and also immune activation. And then all of that together can lead to intestinal barrier dysfunction as well. And this is actually summarized here in terms of the role of mast cells that may contribute to all of those various pathophysiological features. So you can see here at the top, these are different factors that actually can stimulate the activation of mast cells, including neurotransmitters, stress, different food components, in particular bacterial products. So of course, that's what we're focusing on today, different immune cytokines, et cetera. And that can lead to the release of these mast cell granules, which actually contain a lot of different mediators that can then have these effects, many of which can contribute to IBS potentially. Those include proteases, histamine, serotonin, and other immune type chemicals. Those can lead to potentially visceral hypersensitivity, so the pain aspect of IBS, altered motility through their effects on smooth muscle cells, effects on epithelial cells in increasing intestinal permeability, and then also further activating the immune system and leading to chronic inflammation. So you can see here that mast cell activation itself can potentially be involved in most of the major aspects of IBS. Interestingly, there's a number of pathogens and opportunists that are known to potentially activate mast cells. So there's a growing amount of research now that one of the normal roles of mast cells is to help keep pathogens and opportunists in check. So it has antimicrobial activities, partly through those mediators that it can release. But of course, if that's overactivated due to overgrowth of some of these microbes, then that potentially can contribute to excessive mast cell activation in the gut. So you can see here common microbes. These are also on GIMAP. That would include Staph aureus, Streptococcus, Pseudomonas aeruginosa, Enterococcus faecalis, Candida H. pylori, as well as Klebsiella and other LPS and histamine-producing bacteria. So all of these potentially can contribute to mast cell activation. So this is actually a review summary of another major research paper that was published this year, just a couple of months ago, and they summarize their findings here. It says new research in a mouse model shows that bacterium-produced histamine induces abdominal pain sensitivity by a particular histamine receptor, the H4 receptor, leading to accumulation and activation of mast cells in the colon. This study pinpoints Klebsiella aerogenes as the major producer of histamine and a potential therapeutic target in the management of pain and irritable bowel syndrome. So this is really kind of connecting a lot of the dots here. We knew that there was microbial involvement. They hadn't necessarily pinpointed some of the specific species that seemed to be higher in certain IBS patients. And it turns out when they looked at Klebsiella aerogenes in this study, it tended to be significantly higher in IBS patients. And that this particular species was especially kind of prolific in producing histamine. And then that histamine then can cause mast cells to migrate into the colon, and then it can also activate the mast cells. And then the mast cells, once they're activated, can then contribute to the symptoms. So really a lot of dots were connected here in this study. They go on to say that Klebsiella aerogenes abundance was higher in those patients with IBS with high baseline urinary histamine levels, but decreased when these patients ate a low fermentable carbohydrate diet. So that kind of provides another key piece of the puzzle. I think traditionally everyone has thought that a low FODMAP diet mostly acted by reducing gas production, for example, which it may do to some extent, but it also appears that this restriction of carbohydrates, certain types of carbohydrates for some patients, may actually lead to reduced histamine production and improvement in symptoms through that route as well. So really interesting research. And this actually was considered such a notable study that it was just featured in a news review article that just came out last year, yesterday. You can see the date here, November 29th, in one of the major GI journals, Nature Reviews Gastroenterology and Hepatology. So in this article, they noted several key advances in 2022, and this particular study on histamine was the first one listed. And they say here, histamine, a known neuroimmune modulator, is produced by gut bacteria and can induce abdominal pain. Therefore, bacterial histamine is an attractive therapeutic target for treating abdominal pain in IBS. So that's a major advance in IBS based on all this research culminating in this recent study. So let's go ahead and take a lot of this information that we've been talking about here and in terms of some of the microbes and these underlying pathophysiological factors, some of these metabolites, and see how this applies in a particular case example and see how the dots connect here. So this is a case example taken from one of our clinical consultations with a practitioner who scheduled a consultation with GIMAP through our free 30-minute consultation service, where we review patient cases with them and help them understand how GIMAP results may apply to what's going on with their patients. So this is a 59-year-old female who had been diagnosed with constipation-dominant IBS, primarily complained of lower abdominal pain, and noted that it seemed to be especially prevalent when she consumed higher fat foods. So the first page of GIMAP, which is the pathogens page, was clear. Presumably, if she did have post-infectious IBS, then that was in the past, and we're no longer seeing any of the pathogens present. H. pylori was present, but at a very low level. You can see here it's only 1.33 E2, which is far below the cutoff level of 1 E3. Just know that each of these E numbers is an order of magnitude. So the cutoff level is about 10 times higher than the actual level of H. pylori for this patient. So fairly low level, not likely to cause symptoms for most patients at that level. Then we have the commensal normal microbe section. You can see here overall that a lot of these markers are trending to the left in the gradient. So they're on the low side, and then several of them were actually flagged as officially low. Well, that includes the Escherichia, Acromancia, Rosburia, and then also the phyla. So definitely deficiency in the normal bacteria, and we'll talk about how that might be related to this patient's symptoms. Then we have the dysbiotic and overgrowth section, where a number of these were elevated, including Enterococcus faecalis, both of the Pseudomonas markers, and then Streptococcus. And then in the inflammatory and autoimmune related section, we did see both the Klebsiella pneumoniae specific species, and then at the genus level, other species were also elevated, which potentially could have included the Klebsiella aerogenes, although we don't break that one out. So that may be another one. We'll see here, actually, based on some other research, that high histamine production seems to be a feature of multiple Klebsiella species, including this Klebsiella pneumoniae. No fungi or yeast were detected, and no additional viruses. No additional parasites were detected. Now, if we look at the intestinal health page, we can start here at the top with the digestion markers. And the steatocrit was in the yellow range, so it's a little bit higher than optimal. So that's likely related to this patient's symptoms that they notice when they're consuming a certain amount of fat in their diet. So steatocrit is a measure of fat malabsorption. So the malabsorption may be part of the symptom spectrum for this patient. Lactase within the normal range, so no evidence of pancreatic dysfunction. GI markers look good in terms of beta-glucuronidase and no detected occult blood. Immune response markers, we did see that secretory IgA was quite low. Just note that typically follows the general trend of the normal bacteria. That's primarily likely because the normal bacteria primarily produce short-chain fatty acids, and we know that short-chain fatty acids are required to help stimulate normal levels of secretory IgA. So typically, the main cause for a lot of patients of a low secretory IgA is a lack of some of the key beneficial bacteria. Antigliadin was within the green range, within normal range. The eosinophilic activation protein, also in the normal range, and then calprotectin normal as well. So this patient didn't have overt inflammation based on these particular markers. So in terms of the case summary, overall, this patient had low commensal and keystone species, opportunistic overgrowth, including Klebsiella and Pseudomonas, as well as low secretory IgA and elevated steatocrit. So let's go ahead and look at some of these details here and some of the related research to help shed some light on how this may be related to this patient's main diagnosis of IBS-C. So looking at the dysbiotic and overgrowth bacteria section, when patients have constipation, one of the first things that practitioners often think of is methane production. That's kind of due to the focus in the SIBO field on methane as a potential cause of constipation. However, in this patient's case, we didn't see that the methane producers, which is this Methanobacteriaceae family, was actually within normal ranges. And that's typically not considered high enough to result in detectable levels of methane on breath. This patient did not have a breath test, so we can't confirm whether methane was detected on breath or not. But we do know from research that there's a strong correlation between levels in stool samples of these methanogens and breath methane. So because this level is so low, typically to be able to detect methane on breath, the amount of methanogens in the stool would need to be around the E8 range or higher. So this is a couple orders of magnitude lower. This is a review article that just talks a little bit about this connection that we're going to see in a moment between the methanogens and Firmicutes. So this is a quote from that review article. Methanogens are enriched in subjects with the Firmicutes, Ruminococcaceae, and enterotype. So we definitely see this connection a lot for a lot of patients. When they have high methanogens, we'll also often see high Firmicutes. And other research shows that Firmicutes, the phylum Firmicutes, is the main source of hydrogen typically in the colon that can drive methanogens in the colon. So note here in the normal bacteria section that the Firmicutes also was low. So that's probably explaining, at least in part, why we did not see high methanogens. So of course, the question is for practitioners who are focused more on methane as being a potential cause of constipation, is if that doesn't appear to be the case for this patient, what else may be contributing to constipation? And this really illustrates the benefit of kind of casting a broader lens into gut health and see what else may be going on. when the methane story doesn't seem to pan out. So the first thing we want to take a deeper dive into is this low commensal and keystone species result for this patient. Note here that we have low Acromancia, low Rosburia, low Bacteroidetes, and Firmicutes. So these are the key short-chain fatty acid producing bacteria on GIMAP that were low. We do know that short-chain fatty acids are one of the factors that can promote motility. So we can see that here. This is actually one of the review articles we looked at earlier, but just putting it up here again to emphasize that short-chain fatty acids were one of the main types of products that can influence motility. And this is actually a figure kind of looking at this in a bit more detail here. So it's going to get into a little bit about serotonin, which we'll talk about, and how that can influence motility. But you can see here that basically the short-chain fatty acids in this schematic can act through several different routes to influence motility, and in particular on their effects on different cell types. Then these short-chain fatty acids can stimulate the production and signaling for serotonin in the gut. Serotonin is a major neurotransmitter in the gut that can promote motility. So you can imagine that when the short-chain fatty acids are deficient, that may result in reduced serotonin production. There's evidence to support that, which can then lead to reduced motility. So lack of normal bacteria, lack of these short-chain fatty acids, and a resulting lack of serotonin may be one of the factors that could be contributing to this patient's symptoms. Also of note, when you have a lack of normal bacteria, certainly the butyrate producers are an important group of short-chain fatty acid bacteria. Actually, interestingly, it's been known for a while now that butyrate can inhibit mast cell activation. So if patients who have IBS, we know mast cell activation is likely a part of that for many patients. If they don't have enough of these normal butyrate producers to produce sufficient butyrate, then they may not be able to keep that mast cell activation in check. So that can be another factor possibly contributing to increased mast cell activity. One of the key butyrate producers that we have on GIMAP is Rosburia. You can see for this patient that was low. Now let's talk a little bit about Acromancia and its potential role in these symptoms for this patient. It's actually noted recently, and this is an excerpt from this article on the role of the gut microbiota derived signals in the regulation of GI motility. Acromancia is one of the keystone species that can influence motility. And they talk specifically about the research here, that a particular outer membrane protein of Acromancia promotes intestinal biosynthesis of serotonin and further improves the function of GI motility through something called TLR2 signaling. So definitely a lot of accumulating research now that certain microbes can promote motility, partly through the production or promoting the production of serotonin. So when those microbes are deficient, that may be a contributor to reduced motility for some patients. All right, so let's talk a little bit more about serotonin here. So this is a recent review article, Enteric Microbiota-Mediated Serotonergic Signaling in the Pathogenesis of IBS. This is a quote from that article where they say, one of the most important neurotransmitters in the pathology of IBS is serotonin, as it influences GI motility, pain sensation, mucosal inflammation, immune responses, and brain activity, all of which shape IBS features. So clearly serotonin is another product that can be actually produced by certain microbes, but also microbes can then influence the production of serotonin by the gut cells. That can play a significant role in IBS. Additionally, in terms of potential effects of Acromancia, that would be summarized here in this article where they say Acromancia is known to colonize the mucosal layer of the human intestine, where it triggers both host metabolic and immune responses. Acromancia is particularly effective in increasing mucus thickness and increasing gut barrier function. So again, its deficiency may be a contributor both to reduced barrier function, that's often seen in IBS, and also we've known for a long time that reduced mucus production is also something that may contribute to constipation. So there may be additional ways in which lack of Acromancia might contribute to constipation. All right, so in terms of our case summary, we just talked about the potential role of commensals in keystone species. Let's talk a little bit about these opportunistic microbes that were detected in this patient. So under the inflammatory and autoimmune related bacteria, we do see both Klebsiella pneumoniae and then the genus level. So other species of Klebsiella also detected. And we of course know from what we talked about earlier that the Klebsiella aerogenes is one of the species that may produce histamine. Klebsiella pneumoniae turns out to be another one that can produce histamine. That's summarized here in this review article, where they say that specifically certain Enterobacteriaceae, which is a group in proteobacteria, such as Morganella and Klebsiella pneumoniae, have been identified as some of the most prolific histamine-forming bacteria. So potentially a number of different bacteria can produce histamine, and those may be collectively involved in promoting symptoms for some patients. We actually have this resource that I had mentioned earlier, where we have a number of these different types of functional groups listed for you to help you assess patients who have IBS-related symptoms, including those that have bacteria that can produce histamine, mast cell activating microbes, and IPS, or I should say LPS. So this is another section on GIMAP where this patient had opportunistic overgrowth. So you can see here we're going to focus in a little bit on the Pseudomonas, both the Pseudomonas aeruginosa and then also the other species in the Pseudomonas genus. It's been known actually for over 10 years that Pseudomonas aeruginosa is linked to IBS, and that's through several studies, including this one. This was one of the initial ones, where the title is Molecular Analysis of Fecal and Duodenal Samples Reveals Significantly Higher Prevalence in Numbers of Pseudomonas aeruginosa in IBS. We do see this particular microbe elevated frequently in patients that have been diagnosed with IBS. Interestingly, one of the other types of products that was linked to IBS are these enzymes called proteases that some bacteria can produce. Turns out Pseudomonas is one of the key producers of proteases that can stimulate inflammation and have other effects. And that's summarized in this research article here, where they say these results demonstrate that proteases expressed by opportunistic microbes, they featured Pseudomonas in this particular study. They can impact host responses that are relevant to the development of food sensitivities independently of the food trigger antigen. So definitely a key role here in terms of Pseudomonas producing these proteases that then may make patients more sensitive to particular dietary antigens. Just kind of a reminder here, this is one of the review articles we looked at earlier, where they talked specifically about proteases being one of the key factors that can contribute to visceral hypersensitivity. So again, there may be a connection there for this patient. They also noted lipopolysaccharide, or LPS, as another factor produced by the microbiome that can also contribute to abdominal pain. Interestingly, there's this summary here talking about high FODMAP diet causes barrier loss via lipopolysaccharide-mediated mast cell activation. So this is actually linking the effects of FODMAPs to LPS-producing bacteria, and then that resulting in mast cell activation. So they go on to say, we found that a low FODMAP diet improves colonic barrier function and reduces mast cell activation while decreasing fecal LPS levels. That can be yet another way in which a low FODMAP diet has beneficial effects for many patients. Our findings indicate that a high-fat or a high FODMAP diet causes mast cell activation by LPS, which in turn leads to the colonic barrier loss, and a low FODMAP diet reverses these pathophysiological mucosal changes. So a really interesting connection there between these LPS producing microbes and dietary content such as FODMAPs, and then how that may lead to mast cell activation for patients in IBS. So again, these are summarized here in this resource that we have available for practitioners. So in addition to the Pseudomonas aeruginosa in this overgrowth section, we did see a couple of extra microbes that were also elevated. And that includes the Enterococcus fecalis and also Streptococcus, which we do commonly see elevated in patients who just generally are not digesting well. And in terms of their potential effects, again, if we look at this review article that summarized different types of microbes that can stimulate mast cells, that does include those microbes, which again is Streptococcus, Pseudomonas aeruginosa, Enterococcus fecalis, and then Klebsiella, which were all noted for this patient. So this patient may have a sufficient amount of overgrowth that could lead to significant mast cell activation. And again, that can contribute to symptoms. And that's summarized here in terms of the mast cell activating microbes, where we have research evidence that they can stimulate mast cells. So hopefully you can see here through all this research that we covered in the case example that when you're looking comprehensively with GIMAP, in terms of the pathogens, the opportunists that may be present, the balance of normal microbes, what does the immune system look like, what does the intestinal barrier integrity look like, et cetera, you can really get a wide spectrum of insights into what may be going on for individual patients. So I would say kind of the clinical pearl here overall in working with comprehensive stool testing is it really gives you insights into what's going on based on what we know from research, but also it's very individualized. So for some patients, for example, that have IBS symptoms, they've been diagnosed, for example, with IBS constipation dominant. For some of those patients, we do see high methanogens. So methane may be one of the key contributors to their constipation. But for others, we see patterns like we saw for this patient, where they have different types of microbes that actually may be contributing to their symptoms, along with a lack of the normal microbes as well in their products. So having kind of a broader lens to look at gut health can provide you a lot of information to help you sort of sort through what may be going on for each individual patient. So you really can kind of hone in on the details there. So really, really beneficial to use comprehensive stool testing for assessing IBS patients. So thank you so much for listening. You can find additional information on our website. And I know that Adrian will also be talking about how to order GIMAP if you're interested in looking at that as well. So with that, I'm happy to take any questions that you may have.
Dr. Fabian, thank you so much. And thanks everyone for joining us. So we got a ton of questions, and I'm sure we'll continue to get questions as we go through the Q&A. So I'm gonna go ahead and jump in. We'll see how many we can get through. And for those of you who may have joined late or have to jump at the top of the hour, no worries. We always record these sessions, so you will be able to get access to the recording within the coming days on rupauniversity.com, as well as we'll go ahead and shoot you out an email with the recording. So with that, let's go ahead and jump into the first question. So we're going to go chronologically here. So the first question is how to decide what species of probiotics are helpful to restore microbiome for post-infectious diarrhea. Are there any biomarkers that can guide the selection of probiotics?
That's a great question. So there's a lot of research on specific strains that may be helpful. For example, antibiotic-associated diarrhea, so after antibiotics. I don't have that list in front of me. I know there's actually a really good resource out there. I wish I could point you to that specific one, but so the answer is yes, there are a number of different types of probiotics where they have actually looked at the research for specific strains, either in terms of helping to prevent infections or helping to reduce the overall symptoms from an infection. Then there's sort of the types of probiotics that are often used for different dysbiosis scenarios. I would say probably one of the top ones overall would be Saccharomyces boulardii. So that's commonly used for scenarios of Candida overgrowth, H. pylori overgrowth, and even just general dysbiotic scenarios. So it can be helpful kind of across the board. But as far as the research, it's really well documented for Candida and also for H. pylori. So that's another example of something that's commonly included. We can really kind of that could be a whole webinar in itself in terms of which probiotics have evidence for which. But then there's also clinical experience. So I think most practitioners who work a lot with probiotics would say, even despite all that research, so they may use a particular strain because there's a study showing that it works for something, and they find for that patient it doesn't work. So you really kind of have to have your go-to probiotics. Mm-hmm. And a lot of times you end up sort of going through a couple of different products before you find one that's working well for a patient. So there's some trial and error to that process as well.
Great. Does the GIMAP also include zonulin?
It does as an add-on product. So it's not automatically included. It has to be requested at the time that you're requesting the test. So but it's well worth it.
Exactly how to order that very easily on Rupa Health.
Great.
Why are oftentimes SSRIs prescribed for IBS? It looks like it's one of the aggravating factors included with histamine, LPS, so on and so forth. And are you saying neurotransmitters can increase degranulation of mast cells? And one of the substances that are degranulated is serotonin.
That's a great question. And unfortunately, I don't have all the details there. I'd have to go back and look at references to be able to answer that fully. So yeah, I think partly I mean, this is just a bit of an assumption because I'm not an expert in the sort of pharmaceutical end of treating IBS, but SSRIs, of course, we know there's that gut-brain axis connection in IBS, and a lot of patients have concurrent mood disorders, anxiety or depression, along with IBS. But there may be some benefits, based on certain studies to gut health as well. But then, of course, we know that anytime you interfere with sort of the natural process, natural signaling, and serotonin, it has such a big presence in the gut. So if you're disrupting serotonin signaling, I don't really know what kind of research has been done around that related to SSRIs. So unfortunately, I can't comment any further on that.
Can the presence of H. pylori not flagged red on GIMAP still be contributory and a cause to IBS symptoms?
It is something that we commonly see present, and especially high in a lot of patients with IBS. So conceivably, it could be. It's not one of the organisms that's commonly found in research linked to IBS. So that part, doesn't seem to be a strong connection. Clinically, though, you can kind of imagine that probably the most common effect of H. pylori is to reduce stomach acid because that kind of has a whole cascade effect downstream in the GI tract. There's a lot of research showing that low stomach acid can cause dysbiosis, and many of those organisms that are overgrown in IBS can be the same organisms that are increased by low stomach acid. So the short answer is that it could potentially contribute. It's not thought to be a major organism causing IBS. Now, the other thing I want to address real quick is the low levels. We get a ton of questions on that. So some practitioners are just more inclined to treat H. pylori regardless of whether it's high or not. Even if it's detected, a lot of practitioners will still treat it. That may not always be necessary. It's pretty common. About 80% of patients have E2 levels of H. pylori, so these low levels. And the majority of them don't seem to have significant H. pylori related symptoms. So just because it's on the test doesn't necessarily always mean it needs to be treated. That's really where taking into account symptoms are so important because we know that there are many cases, even pathogens on the first page can be present and patients may be asymptomatic. That's really common with C. diff. So again, if you have any questions about how to interpret that information, we certainly encourage practitioners to either schedule consults with DSL or to seek out other sources because that's kind of a key thing to know is pathogens don't always have to be treated.
How do you determine the reference ranges within the GIMAP?
That's a great question. So reference ranges typically involve taking samples from a healthy population and determining what that looks like for the healthy. So it's all done with statistics on GIMAP results with a healthy population, but it depends on the individual microbes. So for the pathogens on the first page, that's largely based on original FDA-approved testing for levels that are more likely to be consistent with a symptomatic infection. So we wouldn't base those types of organisms on a normal population because if you don't have gastroenteritis, you'll have zero usually or very few. So it's going to depend a little bit on the microbe. So it's kind of a complicated answer, but for the normal microbes, that's largely based on healthy population. Then over time, we adjust that based on what we're seeing in terms of results with patients overall. And we also do take into account literature in certain cases if it's really relevant. So it's a little bit of a complicated process, but generally you can think of it as mostly reflecting ranges within a healthy population. So if you're outside of that, you're more likely to have significant imbalances.
Complicated but thorough. Can you do the GIMAP in someone with diarrhea?
Yes, to a point. So our lab has looked into that, and generally loose stools and kind of mild diarrhea don't affect the results significantly. But if you have really watery stool, the density of microbes can drop to a point where you're going to not see the low abundance microbes as well. They may drop below their detection level. So you can miss certain things for patients that have really watery stool. So if at all possible, we do recommend waiting until the stool is reasonably well formed. Sometimes that's just not possible. And it's better to look to see what's there. Maybe they have a pathogen that is detected and you want to know that, even though that may affect the results a little bit.
So are those 30-minute consultations, are they available to both patients as well as practitioners? And do you offer treatment suggestions with the test results?
Great question. So no, they're only open to practitioners who have accounts with DSL. So we're not able to, basically laboratories, can't really practice medicine. So we're not able to give specific clinical advice or medical advice. In consultations, we can address kind of at a high level therapeutic approaches that are suggested based on what we know from research and that are pertaining to the results. But we can't say, this patient should take 8 milligrams or specific amount of certain types of supplements. Right. We can just give general information.
Yeah, that makes a ton of sense. What other tests might you suggest to be ran alongside the GIMAP that are offered by Diagnostic Solutions?
Great question. So it really depends on what you want to look at. I would say the most common overall to run with stool testing is organic acids testing. So Diagnostic Solutions Lab offers, it's more of a metabolomics test. So it includes a lot of the traditional organic acids markers along with some additional ones. And so that can give you some really great insights into overall metabolism, some additional insights into the microbiome. So it's very complementary to stool testing, but they're really giving you two different aspects of what's going on with patients. So that's probably why, in general, in our field, those types of tests are so popular. But if patients are thought to have really significant food sensitivities, food allergies, we do offer that type of testing. If you want to pinpoint what may be causing those in terms of specifics, we do have also a genomic test that looks at a pretty long list of SNPs. So it's the most comprehensive one out there in our field. So again, if you really want to dive into genetics, which can be fairly complicated, so we definitely offer some education and consults for that as well, because that can be, it's a lot of information to try to digest.
Yeah, those genetics tests can be pretty complicated, and even if you consider yourself an expert, they can be quite complicated. So definitely recommend using DSL and all the resources they have available for education on that. Could you mention what your take is on breaking biofilm prior to running the GIMAP?
It's definitely not something we recommend. We don't really have a stance on it officially at all, either way. I think that it's really kind of a treatment if you're going to disrupt biofilms. So I think the idea is that, if some of these organisms are primarily in biofilms, you might miss them if you don't break up the biofilm. There's really not a lot of great evidence yet to suggest that you want to do that. There can be some downsides to doing that before you run a test. You really want to see what's going on in the gut before you decide what sort of approach you're going to take. So I'm personally not a big fan of doing that ahead of time. Because I think you want to base your approaches on the results of the test. So really, that's one of the advantages of this type of stool testing is there's very little that you need to do. It's not like breath testing where you need to do an elaborate prep or fast or anything like that. You're just seeing what the microbiome looks like under the patient's day-to-day conditions. So that's, to me, another really great advantage of comprehensive stool testing.
Yeah, that makes a ton of sense. So calling back to the first case study that you presented there, so the presence of H. pylori within that case study was too low to likely cause symptoms. Does this mean that a higher level of H. pylori, yet still within range, could potentially be contributing to symptoms?
We do see results occasionally that are consistent with that. So even though it may still be in that E2 range below the official cutoff, the closer it gets to the cutoff in general, the more likely it could contribute significantly to symptoms. I think one of the things that we do want to mention, though, is as we have these more precise methods like the quantitative PCR, which is what GIMAP uses, research is showing that picks up more details about the microbiome, including the day-to-day variability. So there's a lot of published research now showing that microbes can increase and decrease on a daily basis to some extent. So of course, with any test, you're just getting a snapshot in time. So you always want to take, even though this is quantitative and the numbers are accurate, it's telling you what's going on at that particular time. So maybe, if you were to do this over every day over a span of a week, an average for that person's H. pylori could potentially be higher overall. So there's kind of that consideration that you want to take those quantitative numbers with a little bit of a grain of salt in terms of the microbes can fluctuate a little bit. So we know it's there, and the more it's trending higher, the more that's likely reflecting the typical trend for that patient. But if you see a tiny uptick or tiny decrease over time after a treatment, patients sometimes really focus on those numbers excessively. And it's like, well, it's still within that E2 range, so it hasn't necessarily changed a lot. So that's a little bit about the interpreting the numbers. Is there a guide, but don't take them overly strictly.
How long do you use the LFM duration-wise?
That's a great question, and I'm not an expert in using the low FODMAP diet therapeutically, so I can't really comment on that. But just in general, I can comment sort of broadly from the microbiome sort of research consideration that it is widely thought that restricting fermentable carbohydrates over time, if it's too stringent of a restriction, can damage or be detrimental to the microbiome. because we do know that fermentable carbohydrates is really the keystone, the cornerstone to a healthy gut. So to the extent that you can really tailor that, a lot of practitioners do that. They might start out more broadly, and then they'll actually kind of dial it in and trial different foods and see, well, which FODMAPs can they tolerate and which FODMAPs. There is research showing that fructans likely are the ones that are most problematic that can lead to this type of inflammation that we were talking about today. So kind of based on research considerations, fructans would be the ones I would be most inclined to consider eliminating.
Interesting. What are your thoughts on people who don't have much overgrowth at all, but are very depleted in good flora and have significant histamine issues?
It's a great question. So the research that I showed just briefly about butyrate inhibit mast cells. So that's kind of a general feature of the normal microbes, is that they produce a variety of factors. Butyrate is just one that helps keep the immune system in check. So they have anti-inflammatory effects typically, and also they can promote immune tolerance. So they can also reduce chances for the development of food allergies. So it's kind of, you have to think of the microbiome as kind of two sides, that you want to have enough of those normal microbes and you don't want to have too many of the bad guys. But even if you just have a lack of the good guys, that already sets up an imbalance. You don't always have to have the bad guys. That could be kind of confusing for people who are new to GIMAP, because we're sort of trained to always look for the bad guys. Mm-hmm. The bad guys are the ones we want to focus on and ideally treat with an antimicrobial if they're significant. But lack of the good guys in research is at least as important for many diseases and conditions. So that alone is a significant finding if they're low in the normal bacteria.
So time for a couple last questions here, and excuse my pronunciation on these rather large words. How do you treat Pseudomonas aeruginosa?
Great question. So probably multifactorial is kind of the best approach. Clinically, we do see that the usual broad spectrum antimicrobial products that practitioners use, these herbal broad spectrum products, seem to work quite well. So we see them, and then patients run a follow-up test, and then the practitioner schedules a consult. And if they walk through what they did for their treatments, we typically will see that Pseudomonas is gone, if not at least significantly reduced. So those do seem to work quite well for Pseudomonas. In addition, we know that common food allergens, especially gluten, can promote the growth of Pseudomonas. So they actually can grow it in the lab on protein purified from milk and from eggs. So it does really well on food proteins, on typically the ones that we think of as kind of the top allergens. So it's a little bit of a chicken and egg that those foods can cause it to grow, but at the same time, it can actually increase the sensitivity to those foods. So that's really one of the key ones. And then inflammation. So if patients have any evidence of inflammation, in general, that's a common factor that promotes the growth of the bad guys. So just an anti-inflammatory diet and inflammatory supplements can also be very helpful.
Perfect. And then one question that we have here is, without naming any names, but there are a number of competitive GI tests on the market. Beyond being a representative for DSL, what really separates the DSL GIMAP from the rest, and why do you prefer it?
It's a great question. So we actually do have a introductory video that we released recently. It's on our YouTube channel that covers. It's basically, I think one of the slides says what sets us apart, and that summarizes it into our markers. We have markers that some of the other tests don't have, like H. pylori is just included, Pseudomonas, a few others. The methods, it's a big one. Quantitative PCR was developed in research because regular PCR and other methods like culture were not sufficiently quantitative. So you could get a better idea of how much is there. There's a lot more we can say about that. That is included a bit in the video. And there's really big differences between this type of testing and sequencing. So sequencing gives you kind of this broad list of microbes, long list of microbes. But the typical commercial sequencing type methods are not nearly as sensitive as PCR. So you can only really see kind of the top most abundant microbes down to a certain level. So those types of tests are not widely recognized as being good for detecting pathogens and opportunists that are present at low levels. So for example, you rarely, if ever, would see H. pylori on a sequencing test because that's just such a low level organism in stool, but we can pick it up with PCR.
Perfect. Well, Dr. Fabian, those are all the questions that we have time for today. If we went through everybody's questions, we'd probably be here until probably midnight for that UK individual attending. But we still got over 100 folks here with us. Do you have any final thoughts to share with everyone?
I think the main thing is kind of as we talked about earlier is it's pretty challenging for practitioners when you are presented with a patient who has these common symptoms. We saw that long list of all these sort of differential diagnoses. It could be SIBO, could be fungal overgrowth, can be mast cell activation, et cetera, et cetera. So really casting a wide net is what you want to do initially. Because if you start going down specific paths, there may be a good reason in some cases to do that. But initially, a lot of practitioners like to just cast that net widely, and that's why they prefer comprehensive stool testing, because you can look at pathogens and opportunists and normal microbes and digestion and intestinal barrier function, et cetera. So that's really, I think, a key advantage when you're assessing patients who have IBS symptoms, or even if they have diagnosed IBS, there's still all these various underlying mechanisms. And if you can identify something specific like Klebsiella, et cetera, that can really give you some great insights that can help you really make a difference for your patients.
Amazing. Dr. Fabian, thank you so much for presenting today. Thank you so much to the Diagnostic Solutions team. We always love partnering with you on these events and just being in general partners with y'all. For those of you who are able to stick around for the next 10 minutes or so, I'm going to do a quick transition into Rupa Health and show you exactly how to order the GIMAP directly on our platform. Dr. Fabian, you're welcome to stick around or you can hop off, but I'm going to go ahead and steal the screen share either way.
All right.
And we
Thanks
can
so much, Adrian.
Yeah, appreciate it.
Thanks, everyone.
We'll talk soon. Awesome, y'all. Well, my name is Adrian Martinez, and I'm the head of practitioner partnerships here at Rupa Health. And so really what that means is it's my job not just to host these webinars and these fantastic educational sessions, but to also be a point of reference to practitioners interested in ordering tests through Rupa Health. So really starting from the top, Rupa Health is a functional medicine lab platform, and we are designed with the goal of making functional medicine more accessible and alleviating a lot of those pain points that can be associated with lab tests. So what we've done is we've created a marketplace. So we've brought on over 30 different labs, over 3,000 different tests onto our platform, allowing you as a practitioner to have a one-stop shop, not only to order your labs, but also manage your results. And beyond that, we'll also take care of the patient experience end to end. So as soon as you press send on that order, we'll ship the kits to the patient, we'll handle all the patient support, all the patient billing, we'll offer multiple different payment solutions, handle any specimen issues, essentially making it set it and forget it, right? Who watched that old infomercial back in the day? So let's see how it works. The first thing I'm going to do is just show you this Discover Labs tab. So the Discover Labs tab will allow you to search for all the different labs that we offer by biomarker, by category, by lab company. You can even search by category here, see all these different categories that we offer. If I expand it out, you can see all the labs that we work with. So as I mentioned previously, we work with over 30 different labs and offer over 3,000 different tests all on our platform, right? Of course, including diagnostic solutions. We have GI tests, we have genetics tests, we have blood tests, you name it, it's all on the platform. And if you're newer to functional medicine or even just looking to see what's on our platform, you can even compare tests. So if I wanted to hit this button that says compare tests, it'll bring up all the GI tests on our platform, and it will break down all the information from everything from cost to turnaround time, sample collection instructions, and of course, even biomarkers. So you can just get the raw data as to what's being tested. Starting an order is extremely easy. You don't need to have your whole patient's profile up. All you need is the patient's first name, last name, and email address. And from there, we'll collect everything necessary to complete the order directly from the patient. Again, the idea here is to make things as streamlined as possible. From there, it'll bring you to the order screen. This order screen is customizable, so you can do things like setting custom bundles. You can create a favorites list. So individual tests that you want to order, you put a heart next to it. And so that way, if I want to order the GIMAP from Diagnostic Solutions, but maybe I want to order a CBC from another company or a allergy test from another company, I have them all at my fingertips. And if that's it, I just simply click send to patient. And that's how I'm able to order the GIMAP within seconds, among other 30 other labs, all in one place. So over here on the right-hand side, once that kit has been added into your order screen, it's simple as any online ordering experience. It's added into your cart, right? But let's say I maybe want to do the GIMAP with Zonulin. I can go ahead and do that instead. It's that simple. I can schedule these orders out in advance. I can add notes for the patient, notes for Rupa, and I can even add ICD-10 codes to the order. So if my patient is looking to potentially submit this to insurance for potential reimbursement, we'll actually automatically create a super bill for your patient. Again, something that is so streamlined and simplified, saving you time and your patient's time as well. How does our pricing work? Sure is a big question on your mind right now. Rupa's free. It's a free platform to sign up for. The way that we generate our revenue is there's a flat 7% processing and ordering fee on each order. And that's paid for by whoever pays for the tests. So what I mean by that is we can manage billing directly with your patients. If you're having us bill your patients directly, then your patients will be the ones in this case paying $25. If that's the way that you're going with billing, then Rupa would be free for you. The alternative would be you decide to pay for the order yourself and bill the patient separately outside of our platform. The cost is the exact same, but you have the chance to add an additional billing on top of that to your patient should you wish. But you can actually do that through our platform as well. So you have the option of adding additional fees to this order as well. So if you want to add on an interpretation fee, you do have the ability to do that. But again, all you're doing is clicking send to patient. From there, we'll reach out to the patient, ship the kits to them, send over any instructions and FAQs, handle any specimen issues, basically take care of everything necessary for the patient to complete this test. And the only cost is that 7%. Once that patient completes that test, you're able to hop right back in here and you can manage all of your results directly within this dashboard. So I can click this open and I can see, hey, here's 4 tests from 4 different labs. I can see here's my GI map, the invoice has been paid, or I can see when the sample arrived at the lab, when I can expect the results to come in. It's all available. And once the results are in, you're able to download the results. You can send these results directly to your patients. We won't send the results to your patients without your consent. You can also schedule a clinical consultation. I know that's something that Dr. Fabian mentioned a number of times. You still have access to the ability to schedule consultations with the lab that you're ordering from. So you don't lose anything that you would be working directly from the lab that you are if you are working through Rupa. So one-stop shop to order from 30 plus labs in one place, to manage your results, to have your patient experience taken care of, and it costs nothing to sign up for. That 7% processing and ordering fee is the only cost to work with Rupa, and that's paid for by whoever pays for the tests. So if you're having us just bill the patients, then you'll never pay a dime to Rupa. The last thing I want to show you all here is Rupa University. So Rupa University is the educational component to Rupa Health. You've actually all just watched a Rupa University video. So this is the one right here with Dr. Tom Fabian, but you'll see that we have created actually hundreds of these videos. And so you have access to the entire library along with the slides on 95% of these videos. So you can download them and follow along as you're rewatching. We have a magazine, we have a podcast, we have tons of resources available. So beyond a place that you're just coming to order all your tests, we want to be a place where you can come and continue to learn as well. So again, Rupa Health, it's free to sign up for. Check it out at rupahealth.com. But if you do have any questions, this is my contact information. Again, my name is Adrian Martinez. I'm the head of practitioner partnerships here at Rupa Health. And so if you do have any questions, feel free to reach out to me, whether it's via email or via phone. Always make myself available to you as a practitioner because I want to ensure that you are set up for success. So thank you all so much for joining us today. We hope to see you again. We actually have another one tomorrow. We're doing a 2-for-1, not only this week, but we have 2 next week. It's crazy coming into the holidays. We want to ensure that we're getting all of our partners in. But if you do have time to join us tomorrow for an amazing presentation with Dr. Cheryl Burdett, please join us then. Additionally, we have one on Monday with Dr. Dickon Weatherby, the CEO and founder of Optimal DX, and then another one the following week with Infinite Allergy. So with that, folks, again, my name is Adrian Martinez. Thank you so much for joining us. If I don't see you again, hope you have a happy holidays, and we will talk soon.